Thread Overview, Part 3. How does Thread compare? Welcome back to Silicon Labs Thread Overview. This is Part 3 of a 3-part series. In this final installment, we'll look at how Thread compares to ZigBee Pro and other wireless networking technologies you may know. One thing to keep in mind about Thread is that it's an 802.15.4 based networking stack and not a complete application layer, much like the 802.11 based Wi-Fi standard. This means that it can be used to assemble networks and to help convey messages through a network and across networks, either by one-to-one unicast messaging or by one-to-many multicast messaging, but the actual payloads of data being conveyed in those messages is the responsibility of the application designer, and the expected outcome of those messages is to be defined by the application layer. Simple or highly efficient messaging protocols based on UDP are appropriate for Thread, but any IP-based application layer could theoretically be used, such as IPSO, AllJoin, or HomeKit. Application layers that aren't already IP-aware would need some custom adaptation to run on top of Thread. For example, an effort is already underway within the ZigBee Alliance to adapt the ZigBee Cluster Library, ZCL, to a more IP-friendly application layer so as to make it more suitable for IP-based stacks like Thread. To help ensure in-network compatibility between Thread stack implementations, the Thread group's working with UL-affiliated test labs to provide compliance testing against the stack standard. Although this testing doesn't focus on the application layer, stack-level functionality like commissioning, routing, joining, security, and message propagation are all verified by this testing process, and a test harness will be provided to member companies to validate the stacks in advance of official compliance testing. While the IETF standards-based stack elements can be verified by the aforementioned UL testing, true interoperability between Thread-based devices requires agreement about which application layer to use. Application layer behaviors that need to be agreed upon and tested for interoperability include device and service discovery, pairing of complementary devices such as a switch and light, specific command and response formats and behaviors for various kinds of devices, and required functionality among similar devices from different vendors. Any vendor-specific enhancements to a standard application protocol will need to be discoverable by some standard process and added in a way that doesn't compromise standard functionality. Now let's look at Thread in comparison to some other wireless networking standards. The one people know best is Wi-Fi, based on IEEE 802.11, and this certainly has the best adoption rate in the home and the advantages of being IP-based and supporting high bandwidth in multiple frequency bands. However, Wi-Fi currently does not offer any mesh networking capability, so it requires a star network topology built around an access point. It's also heavy-handed in its use of the radio, so it draws more power than its peers, making it undesirable for battery-powered devices. Next we have ZigBee Pro, an 802.15.4 based mesh networking standard used in Silicon Labs' Ember ZNet stack offering, and one that has seen steady growth over the last decade. ZigBee Pro addresses the shortcomings of Wi-Fi and positions itself much better for a widespread network of interconnected, low-power devices that don't require nearly so much bandwidth, and that makes it similar to Thread, except that ZigBee stack layers aren't IP-based, nor is its application layer, although the ZigBee Alliance has announced plans to rectify that. That means that any communication off the local ZigBee Pro network needs a proprietary gateway to manually proxy the packets and the payload back and forth. Furthermore, the ZigBee network architecture concentrates a lot of responsibility on the network coordinator for commissioning and security, making this a potential failure point for the network. We'll do a deeper comparison of ZigBee Pro and Thread in a minute, but first let's look at some other standards out there. Some of you may have heard about ZigBee IP, an effort by the ZigBee Alliance to come up with their own IPv6-based stack based on IETF standards and targeted at customers in the smart energy market. And this would be used in conjunction with the ZigBee Smart Energy 2.0 application layer, SE 2.0, which was also designed to be IP-friendly for communication with the utility backhaul networks. While still an 802.15.4 based mesh network at the low levels, much like ZigBee Pro, the higher layers more closely resemble the full TCP IP stack model used with Wi-Fi, and in fact ZigBee IP was designed to also support 802.11 as an alternative MAC and PHY. This resulted in a stack that was lightweight from the perspective of designers used to complex and powerful Wi-Fi enabled systems like laptops, smartphones, and some of the more sophisticated electric meters, but too cumbersome from a resource point of view when it came to memory, bandwidth utilization, and power consumption on an embedded device. As such, this stack has yet to gain wide acceptance among utility companies and device manufacturers currently leveraging ZigBee Pro and SE1.x. It lacks the efficiency and scalability of ZigBee Pro or Thread, and its target market is admittedly the smart grid rather than the smart home. Next we have Z-Wave, a proprietary sub-gigahertz home control standard designed and controlled by Sigma Designs. Although lacking the large-scale mesh networking capability of its ZigBee counterparts, Z-Wave often achieves wide coverage of the HAN via increased propagation of signals in the 915 MHz band, and its low power consumption and established vendor ecosystem have made it successful in the North American market, especially in the years preceding wide adoption of the ZigBee home automation standard by many device vendors and MSOs, major service operators. However, Z-Wave's limited security and scalability and its single-source supplier model have inhibited its growth in new markets and use cases, and its application layer is currently not IP-based. Also, because of its lack of mesh routing capability, the network is dependent on a single central router for the bulk of its connectivity, meaning that it is vulnerable to device failures and changes in connectivity in ways that Thread is not. In contrast to these standards, Silicon Labs' Thread stack provides a good balance of low power consumption, full mesh connectivity among multiple routers, distributed responsibility and intelligence to allow the network to adapt to changing conditions, true IPv6 support for direct connection to other IP-connected devices, a UL-tested set of international open standards implemented by multiple stack vendors, and a simple means of internet connectivity via one or more border routers without the need for application layer gateways. While Silicon Labs believes that Wi-Fi will continue to have a place in the home for many years to come, partly due to its ubiquitous nature and partly due to its generous bandwidth across several frequencies, we believe that our Thread stack, when combined with one or more standard application layers, will provide an ideal solution for bringing the Internet of Things into the home, as it offers many of the advantages of the already successful ZigBee Pro stack, with the added benefits of seamless IP connectivity and a set of IETF standard technologies designed for worldwide use. Since Silicon Labs offers stacks for both Thread and ZigBee Pro development on its wireless SoCs and network coprocessors, let's spend some time comparing these two technologies in more detail to help you decide which one is right for your particular development. Both ZigBee Pro and Thread are based on the IEEE 802.15.4 MAC layer, but ZigBee Pro leverages the 2003 version, and then the higher layers employ ZigBee-specific protocols designed by ZigBee Alliance members, including the ZigBee Cluster Library Application Layer, ZCL. AES 128-based security is provided at the network layer. Thread uses the 2006 version of 802.15.4, which allows it to make use of MAC layer security for AES 128 encryption. Higher layers are all IETF-specified RFCs, with the exception of the application layer, which is not specified by Thread. ZigBee Pro's origins date back to the original ZigBee Stack release in 2004, which was later revised in 2006 to include support for an expanded feature set, which ultimately became ZigBee Pro in 2007. The ZCL application layer dates back to 2006, but continues to evolve as new vendors and new device types expand functionality of the standard. Thread is a new stack developed in 2014 and 2015, with its first public release in July 2015, although it includes well-known technologies like 6LoWPAN, IPv6, and UDP. ZigBee Pro is in wide deployment among smart energy, home automation, and commercial lighting use cases, with over 50 million devices shipping worldwide in 2014, and 2015 is expected to easily exceed that figure. ZigBee Pro-based home automation systems are available at most major home furnishing retail chains in North America, each with a multi-vendor ecosystem of connected devices. And ZigBee Pro is used by British Gas to provide energy monitoring and smart metering solutions in the home for millions of customers across the UK. These kinds of widespread multi-vendor ecosystems don't yet exist on top of Thread, as the standard's new and doesn't specify an application layer, although Google's Nest Labs, as a principal architect of Thread, has already begun to leverage Thread as part of its Works with Nest developer program. In ZigBee Pro, Stack certification and ZigBee End Product certification are well-established processes supported by multiple test houses and have been demonstrated across several stacks and hundreds of end products. Thread's UL-based stack certification program is only just available with the release of Thread 1.0, and of course it won't cover the application layer, so end-to-end product interoperability can't be assured through this testing alone. ZigBee Pro's ZCL application layer is based on years of continued development and input from many product manufacturers across several countries and target markets. Its proven success in the home and smart grid offer a high degree of confidence for devices working together, and the vast majority of ZigBee-based devices leverage the ZigBee cluster library for their application design. Meanwhile, Thread doesn't prescribe any particular application layer. What it does is provide standard end-to-end protocols like UDP, CoAP, and DTLS to convey basic data packets between any two IPv6-enabled devices anywhere on the internet, potentially over a secure connection. The application developer can then apply any IP-based application layer on top of these basic transport mechanisms, with the choice of app layer being driven by either a need for compatibility with a certain set of devices or the particular strengths and familiarity of a given protocol. So in summary, Thread is a full IPv6 stack for wireless embedded networking, offering more than just the 6LoWPAN address translation, but also proper in-mesh and off-network routing, addressing, discovery and failover mechanisms for devices and routes, inter-device and end-to-end security, basic unicast and broadcast messaging protocols, and support for duty-cycled battery-powered devices. Thread is also robust due to its ability to adapt to changing network conditions and its failover mechanisms, which work to avoid a single central failure point. It's an entirely standards-based stack model utilizing IEEE and IETF specifications and employing UL approval processes for ensuring stack compatibility with the required set of features. And best of all, Thread is hardware compatible with many 802.15.4-based SoCs and end products already on the market, as its hardware and software resource requirements are similar to that of a ZigBee Pro stack. It uses a similar MAC layer implementation on top of the 2.4 GHz DSSS PHY and adds MAC layer security. The advent of new sub-gigahertz PHYs in the 802.15.4 space could even make Thread feasible for other frequency bands as well. In fact, Thread could even be deployed to existing ZigBee Pro-based networks using ZigBee's over-the-air upgrade cluster to roll out Thread-enabled firmware to already installed devices. Like Silicon Labs' EmberZNet solution for ZigBee Pro, Silicon Labs Thread supports both the single-chip SoC approach, where the full stack and application are linked into a single binary on one chip, and the two-chip network coprocessor, or NCP approach, where the base stack implementation resides on the SoC but functions as a coprocessor via a serial interface to a host MCU running the application layer. This NCP approach is ideal for border routers or other devices where there's a complex system in which Thread plays only a peripheral role. Thanks for learning more about the Thread stack and Silicon Labs mesh networking solutions. To help you in your continuing education about Thread, here's a list of common acronyms used in this presentation and in general discussion of Thread.